Hi, welcome to my easy algebra tutorial on using algebra to solve geometry problems. I love when two maths combine. Now, even though this is an algebra tutorial, we're going to be diving back into some older math today. So to kind of get us warmed up, I have three shapes, and I want you to just pause the video, find the perimeter and area of these three shapes real quick, and then restart to see if you got the answers correct. So on the screen, I have all of the answers for the perimeter and area. You can pause here if you'd like to take a moment to check your work. There are a couple of things that I would like to point out because I am an algebra teacher, and so of course I have to say something about this. You'll notice anywhere a formula could be used, I use that formula and I wrote it down. That's actually going to be super important for what we're going to be doing on the next few slides. Another thing, I don't have the units written in my answers. Ordinarily, we definitely want to do that. So for example, the triangle is not 24 for the perimeter, it's 24 units. And for the area, it would be 24 units squared. Just something to keep in mind. All right, let's try something a little bit different. Now, I totally recognize that these two shapes look extremely similar to the ones you just saw on the last slide. But there is something slightly different that's going to make these a little bit more fun and algebraic. We have expressions for some of our side lengths. So this is going to be done a little bit differently. I want you to just try on your own finding the area and the perimeter of these two shapes. Pause the video, see what you come up with, and then hit play when you're ready to check your work. Oh man, I really hope that you had as much fun with these shapes as I did. So the process here is actually exactly the same as what we saw on the last slide. For example, for the perimeter of the triangle, all you do is add up your three sides. The difference is we have a variable instead of a number here. Well, it's still the same process. I add up the three sides. It's just that it's going to give me a simplified expression by combining like terms. Same thing with the area. I pull the base and the height, multiply them both together, times 1/2, and I just get a simplified expression from using the distributive property and combining like terms. The same thing happens with the rectangle, and this is why it is so important to use those formulas. I know the perimeter is 2 times the length plus 2 times the width. This time we don't have numerical values, we have expressions. So 2 times the length, our length is an expression and we have to use the distributive property. 2 times 12x gives me 24x. 2 times -4 gives me -8. And that's how we're going to build our perimeter. So it's this concept right here that we're going to be using to now move into solving equations. For these equations, just some quick tips to help you move forward. The first one is make a plan. What information do you have? Are you told what shape? Hopefully you are, since these are geometry problems. Are you given the length? Are you given the width? Are they numbers? Are they expressions? It's extremely important just to know what do you even have to start with. Then what are you looking for? Are you just looking for the value of x, or do you have to do something with x? And then basically what steps are needed to get you from the information you have to the information you need. Oh my gosh, my biggest tip is know your formulas and write them down. It's one thing to know off the top of your head when there's no pressure that the area of a triangle is 1/2 base times height. But given a problem about the area of a triangle, if you don't write that down, it is so easy to make a small mistake there, and then all of your work is wasted because it's going to give you the wrong answer. And the last piece is make sure your measurements make sense. This is kind of a logical check step. If your values are very small on the shape, but you end up with this astronomically huge answer, you know that that answer doesn't actually make sense. And we're going to get some practice with that today. So let's get started. Example number 1. I have a rectangle. It says the perimeter of the rectangle below is 67 inches. What is the value of x? So the very first thing I want to do is I want to pause and just think to myself, what information did they give me? They gave me the perimeter is 67. And then if I actually look at the rectangle itself, they gave me the value of the length and the width. So let's just pause for a second and think to ourselves, what formula do I need? Our formula for the perimeter of a rectangle is 2 times the length plus 2 times the width. Now let's go back. What information from this formula did they provide us? In the word problem itself, they gave us that P equals 67. Okay, but they gave us other information too. They gave us the information on the rectangle itself. To make this a little bit easier, I like to actually go in and annotate on my shape. So I'm going to do L is equal to 2x plus 1, and W is equal to my 3x. Now I have enough information to get this problem started. Always start with your formula. Now that I have my formula in place, I just need to substitute in all of the different values we see. So to start with, we have our perimeter. We also have the values of our length and width. And once we have everything substituted into the equation, it's just a matter of going through the solving process. Because this tutorial is focused primarily on the geometry and not solving multi-step equations, you can just pause the video here to check your work and see if your answer is correct. After working out the problem, I have found that the value of x is going to equal 6.5. Now I do want to go back and double check against the original problem to make sure, is this what the problem was asking for? So going back and looking, what is the value of x? We have the value of x. We are done with this problem. Now let's go on to another question. Example 2. The triangle below has an area of 39 centimeters squared. What is the height of the triangle? So just take a moment, check out what information you have from the problem and what information you need. When you're ready to work the problem through, hit play. So breaking down the information given to us, we know the area is 39 centimeters. And so because we know the area is 39 centimeters squared, that tells me we need the area formula for a triangle. We also know the base of the triangle, and we have an expression for the height, which is important to note because the question is asking us for the height. So we're going to need to figure out that piece of information at the end. Now that we've come up with everything the problem gives us and what we're looking for, go ahead and pause the video to write your formula and substitute in your values. Press play when you're ready to move on. You should be using the equation A equals 1/2 base times height, because that is the equation for the area of a triangle. We'll substitute the 39 in for the place of A. The base will be 4, and the height will be 2x plus 5. From this point forward, you just distribute, combine like terms, and solve as normal. Go ahead and pause, find your solution for the value of x, and then hit play to see what we're going to do with it after that. After working your way through the problem, you should get an x value of 7.25. However, if we go back to what the question was asking us and the notes that we took over here, it's not the value of x that we're looking for. We're looking for the height of the triangle. So if the height is 2x plus 5, and we know that x is 7.25, how are we going to find the height? To find the height, we're going to use that expression 2x plus 5, and we're going to substitute in our new value of x that we just found. From there, we can calculate the height of this triangle is going to be 19.5 centimeters. This is why it's so important to look at what information you have and what you're trying to find multiple times throughout the problem, because it would be so easy to get that x value and just stop there. But in this case, we actually had to do something else with it. So now that we've been over how to solve these types of equations, I have several examples that you can just try out on your own to test your newfound skills. So for each of these examples, pause the video, try them out on your own, and when you're ready to check your answer, just hit play. So the first example is example 3. You can pause now. If you've completed this problem, you should have that the area of the circle is 50.24 inches squared. One thing that I like to do for these types of problems is write a sentence about the solution before I actually find the solution. So this question was asking, what is the area? I wrote the area of the circle is, and then left a blank until the end. So that way, when I got to r equals 4, if I tried to fill a 4 in here, I would recognize, oh, hey, this is area. I found radius. I'm not done. So just another helpful hint as you're working through these problems. If you're ready, let's go ahead and move on to the next example. In our next example, example 4, our problem does require that you know some basic geometry vocabulary. In this problem, it reads a regular pentagon. If you're not aware of what that means, a regular pentagon means a pentagon in which all of the sides are the same length. Anytime you see that word regular in geometry, whatever shape it is, all the sides have the same length. You've already worked some other problems. Hit pause to try this one out, and when you're ready to check your answer, hit play. So let's break this problem down. We actually had a lot of information about our perimeter. We know that the perimeter had 4x minus 7 as its value. We also know that since this is a regular pentagon, the perimeter is just 5 times the side length, which the side length is x minus 3. So when I created my equation, I set the value of the perimeter, 4x minus 7, equal to 5 times the side length. Solving for x, I've received the value of x equals 8. However, going back to what the question actually asked you for, it asked you for what the perimeter of the pentagon was. So you had to take that 8 in, substitute it into your perimeter equation to find the value of the perimeter was 25 centimeters. I almost forgot my units. How dare I? All right, we have, I believe, one more example. Let's try this one out. I decided to get really fun with example number 5. If you can do this one, I truly believe that you can do any of these geometry problems in your algebra class. So go ahead, pause the video, try this one out. And if you get stuck, or if you want to check your answer, hit play to see an explanation of my work. All right, let's break this problem down. Now, I do have to apologize in advance. There is a lot of work and a lot of stuff going on my screen. So I'm going to break it down for you as best I can. To start with, I looked at what we were told. We knew the perimeter of the square was equal to the perimeter of the rectangle. Well, I know a square means that you have 4 equal sides. So to find the perimeter, it's just 4 times the side length. But with a rectangle, it's 2 times the length and 2 times the width. And we were looking for the area of the rectangle at the end. So I knew I was going to have to use the area of a rectangle equation. So to start with, we were told that the 2 shapes had equal perimeters. So I took the perimeter formula for the perimeter of a square, and I set it equal to the perimeter formula for the perimeter of a rectangle. Then I substituted in the side length. So the side length of the square times 4 gave me 24x minus 4. I substituted in the side lengths for the rectangle. Simplifying those, you end up with 12x plus 20. Solve that equation and you get an x value of 2, which is great, but that's not what this equation was asking for. This question was asking us for the area of the rectangle, and we now have the value of x. So next I said, okay, the width, 2x plus 4. If I substitute the 2 in, I get a width of 8. My length is 4x plus 6. If I substitute the 2 in, I get a length of 14. So now I'm going to use my area of a rectangle formula, which is area equals base times height. And in this case, we can substitute in length times width for base times height. 8 times 14 gives me my final area of 112 units squared. Whew, that was quite the problem. And now that you have survived that last example, I know that you have geometric applications of solving equations totally down. The guided notes for this video, as always, are available on my Teachers Pay Teachers store. I have the link below. I want to also thank the Storytime Sprout website for their amazing light bulb clip art. I just thought it was super cute with its little calculator. And as always, if you have any questions about today's tutorial, please feel free to ask me in the comments. I'm happy to help out. And if you have any other algebra that you are stuck on or that you have suggestions for a tutorial video for the future, let me know that too. I can make an easy algebra tutorial on any algebra concept. All right, take care and happy learning.